Now I am recording. So, with functions, there's a few things that you should already know how to do. So, if I give you a function like this, f of x is x squared plus 2, I said g of x is 2x plus 3, okay? Few things that you should already be able to do is, for instance, tell me what that is, and tell me what that would be, for instance, what the difference would be. So when I'm doing that, what am I doing?
Substitute for a.
Thank you. Substitution. And when I'm doing this, I'm
Folding.
okay. So this one, I'd be saying substituting. I'd be saying, well, I want to know what f of 4 is. Okay. So we'd be looking, apply the function to 4. So I'm looking at the function f. I'd be saying it's 4 squared plus 2 equals 18. So I can say f of 4 equals 18. Right, so we are just substituting it. This one, I'd be saying that 2x plus 3 equals 8. So I'm looking to find what x is. So that's 2x equals 5, so x equals 5 over 2. Okay? Yes, ma'am?
Well, I'm assuming there's a test, like, going to be on this.
Can we not talk tests?
We're here to
I don't like talking about tests
Well,
before we get to it. We're learning.
okay, just a question to improve my learning.
Okay?
Those formulas,
Formulas? What
or
formulas?
like functions, yeah, we'll have to memorize that, like, when they say f, when you say, like, f, bracket x bracket equals x squared plus 2. F,
Yeah, f of x.
We'll have to know that.
It's not always.
Well, it's not always x squared plus 2,
It's
right?
not set in stone.
F of x is like y.
It's never set in stone.
Yeah, okay, just to clarify.
So y equals or y equals. Yeah. Okay. Also, so we've done that. I should be able to ask you to state the domain and range of both of those functions at the moment.
Oh, okay.
Okay.
So that these two should probably be quite easy, no?
Yeah.
So the domain, let's say, of f of x and g of x. So what's the domain of f of x then, Tiro?
X is can be anything. A
Any real number.
Any real number, yeah. What's the domain of g of x?
X can also be any real number.
Any real number. What's the range of f of x?
Oh,
So hopefully now you know what the shape of x squared plus 2 looks like. Draw it with your finger in the air. All of you.
It's like a parabola.
It is. Yeah. Yeah. And hopefully you've realised it goes
look at you.
u going upwards.
From the 2.
So what's the range from the 2 it's done, yeah?
So we use x can be any
No.
number, however.
No,
I was saying however.
no.
What?
First thing you said was incorrect.
X.
No.
Y.
Okay.
Y can be any real number, however, y must be greater than or equal to 0. Wait, no.
2.
Because 2 is the m, or in the situation, if it was y
The
instead
plus
of 1.
c, yeah. Exactly. Remember it's f of x, I'm looking at x squared plus 2.
Oh, we're looking at that one, sorry.
What's the range of g of x?
Y must be greater than or equal to 2.
No.
3.
No.
4.
No.
Y is any real number,
Y is any real number.
Oh, yeah.
however.
Nope.
Because there's no square in it,
Right.
in the
It's a
equation.
straight line that goes on forever, yeah? There's no limit to it. Goes on forever. So hopefully you'll start to realise that if I've got a straight line, there's any x and there's any y that I can have. Yeah, if I pick the right x, I will get the y that I want. There is no value of x that can't go into a linear function. Okay? Yeah?
Wait, I just missed something, I think. Yeah.
And that's because if we sketch these, ooh, that's a new one. Not that one. This one. So if I sketch f of x, do you notice how I'm starting to use the language? So I'm not having to say I'm going to sketch x squared plus 2. I'm saying I'm going to sketch f of x.
Oh, okay.
And because you know what f of x is,
X squared plus 2.
so that's how we use our communication, we use our function notation for it. So when we're writing, I can state f of x and g of x at the top, and then just write, well, now I'm going to do f of x plus f of x, that's the whole point of it. So x squared plus 2 looks something like that, yeah?
Yeah.
Goes on for infinity up there, crosses there at 2.
It doesn't
That's-
go up vertically though, right?
No, it goes on in a parabola, like you said, a U shape. So I know when I consider the x values, the domain I'm looking at, is there any value of x that I can pick where there won't be a point on the line? No. That line will always go off forever, yeah?
Yeah.
Okay. Now, what I then can say is there any value of y that I cannot achieve by choosing the correct value of x?
Yeah.
Yes, there's lots of them. There will never be, so any of these y values will never be achieved, will they? Everything above that, however, will be achieved. Yeah? So that's why we say y has to be greater than or equal to 2, because the line itself is on 2, that's why it's there. Because remember, a line is an infinite point. Yes?
You really have to write y as any real number, or can you just
Technically.
write y equals greater than 3?
Well, I wouldn't worry about it. If you just wrote y was greater than 2, greater than or equal to 2, I'd be alright. But we need to get used to it, because other people are going to write it. Yeah? So that's what a quadratic would look like. And if I have the straight line, my linear function, we've talked about these a lot. So 2x plus 3 looks something like that, doesn't it? Okay, crossing at 3. So that would be 2x plus 3. So then we're saying any value of x I can choose, I will get a value of y out. Any value of y that I want, I can get by picking the right value of x. Okay, so there's no limit to the domain and range. But we started looking at different functions with different limits. So when we have an exponential function, so an exponential function, for instance, looks like
I don't know what happened to my hand up. No, wait. No.
yeah, like Ethan said, it goes like this, doesn't it?
Goes up like.
It goes up exponentially.
Yeah. I don't know, like.
What is
Going
what is this line called?
The asymptotes.
That's an asymptote.
No things.
In this case, that is the asymptote. It's not always the axis.
sometimes it's
Yeah, it might be up. No, it also could be higher or lower. If I write a different, if I look at a line with an asymptote that's down here, okay, if I change the function slightly, then the graph would look like this.
And that yellow line and this line right
that would be the asymptote.
Really close to
Yeah.
it.
Now this would be the asymptote. Right? So, but that an exponential function will have that type of property where it will have an asymptote on that. So again, that affects what does it affect? The domain or the range?
The range.
The range. So the range is limited, isn't it? With the range, we say in this case, y cannot be less than or equal to the asymptote, right?
How would you write that?
Y is greater than
So,
2.
so for this one, obviously for both of them, x can be anything, but this one I would say y would be must be greater than 0 in this case. But this line here, again I've got x can be any real number, but y must be greater than, should we say it's minus 5? Negative 5. Whatever the
So
function.
it's just not like greater than any.
And why is it not equal to?
Because then it would be an asymptote.
It would be an asymptote, yeah, that's the whole point of an asymptote. It will never actually equal it. But up here, it is equal to that 2, isn't it? The line actually is on 2. On the asymptotes, it's not there. So the other type of function we did consider with asymptotes was one that looked like this.
Oh, no one has 2 asymptotes.
That one has 2 asymptotes, doesn't it?
Those both increase
Anyone know
and
what it's
decrease
called?
exponentially.
It's like a 1 over
A
x.
diasymptote.
Oh, it's 1 over
The
x
type of
squared.
function.
Oh,
So
you
we've
mean the
got
function, sorry.
quadratic,
Oh, exponential.
not exponential, that's an exponential.
That one's exponential.
That's exponential on the left.
Those ones are.
This one is called, and you'll go, oh, yeah.
Mononomial.
No, it's called a
Reciprocal.
reciprocal. Because what's the reciprocal of a fraction?
A number.
Itself. The denominator.
Fraction upside down, right?
Oh, that's just something, like, the denominator.
No, the reciprocal of a fraction
Denominator's a whole number.
is the fraction upside down. No.
Yeah.
If you find the reciprocal of something, you do 1 divided by that something.
Oh, yeah.
So
So then,
1 divided by 2/3 is 3 over 2.
over 2.
So 1 divided by x gives you the reciprocal of x. Therefore, it's called a reciprocal function. And we have a problem with, we have a limit in the range and the domain. Okay?
What's the one that has a half parabola?
Half a parabola.
Yeah. What's that?
I don't think we had one that was half a parabola.
It wasn't it like.
Oh, I get. So we looked at the square roots. So we looked at one that actually, and this is when we start looking at inverse functions. One of them would look like that, yeah.
That one.
But if we considered everything, it would be like that, yeah.
Yes.
Yeah.
But it's not a.
And then it's.
It's not a.
Not an exponential.
Not a function.
Not a function.
It's not a function.
Oh, because if any vertical line can go through it twice, okay.
All right. It is a
A relation.
relation. Okay. Okay. So we've got that. So normally we wouldn't consider the bottom half of it. We would only have this top half. Okay. Like a logarithmic function that we need to look at later on as well. Okay. So we've got this.
You still have to know it's a function. Even if they only have the top half.
Yeah.
Because you have
Yeah, so we'd have to say to treat it as a function, we'd have to know that we're really dealing with the positive values.
Oh.
Alright, yeah, so we've got all of those, we've done domain and range. What we did think about was this one where if we were combining 2 functions, so remember I said if we have x squared plus, what did I have, 3x plus 2 divided by x plus 2.
X could not be 0. X could not be -2.
Okay. But if I simplify that, so we would say x cannot be -2, so that would change the thing.
How-
Is it equal to 0?
Huh?
And then a fraction here equals 0 1.
Oh, okay.
Because that is
Yeah.
in the fun. Example.
But what we also looked at was if we factorise that, what was it, x plus 2, x plus 1, all over x plus 2. Do you know what I'm doing when I do that?
Trinomial factory.
So then we cancel out that and we're left with only x plus 1, which looks like a function that has no problems with domain and range. However, what would the domain be of this function?
Any real number.
X still can't equal minus 2.
Yeah, any real number. not-
Even though if it was a function just on its own, it would be anything. But because it's come from something else, so that's what we did last week, wasn't it? Sorry, yeah, last lesson last week. We talked about if functions come from somewhere else. And that's important because when we now look at composite functions, we need to look at composite functions and understand domains and range. So, if I said we've got f of x is x squared plus 2 again, and g of x is 2x plus 3, if I asked you to tell me f g of 3, what do you reckon, Zoe? Sometimes it's written as
times u of 3.
not times.
X.
No. What do you reckon, T-Ray?
X squared plus 2 times 2x.
It's not. It's a good. It's what it looks like, isn't it? It looks like you do times the 2.
Oh, is it
Is that a new symbol?
It's not plus. Remember the one you saw earlier when we added the functions, you could add them.
Is it a function symbol?
This is a compound, composite function.
I
Okay?
should have known it was the title of the.
Yeah, it's a composite function. This is where you use one function and then the result of that function gets put into the next function. Okay? So basically what this means is, by looking at it in a different way, 3, so x is 3. And what we do is we put it into one of the functions first. Which one do you think? No. Which one do you think? G. So we do g of 3 first. Why do you think?
Because it's not touching the brackets.
Exactly. It's g3, and then we do. Sometimes people also write f g x. So f of g of x. So f of g of x.
Oh, that kind
Makes
of
sense now? Yeah.
With the brackets.
I tend to just write it like this, but I see it like that, especially in textbooks. So what we do is we stick 3 into g of x, figure out what it is, and then put that solution into f of x, and see what comes out. Okay? So we'll go 3 in, what comes out?
83.
So 2 times 3 is 6, 9. And then we put 9, so we do f of 9 equals 83. Yeah. So fg of 3 is 83. Simple as that. Alright?
Sorry, I was. How did you just plug it together?
Well, if I put 9 into f, what's 9 squared?
9 squared is 81.
Plus
oh,
2.
plus 2. Okay.
Yeah?
So f
Thank
x
you.
is
For explaining.
So that's easy enough, right?
Or no, f9 equals 83.
So if I asked you for, so f of g of 3 is 83, just rewrite that. What would f g of minus 2 be? What would gf of 7 equal?
3.
Well, I'll tell you, write them down in your book so you've got some notes, and then we'll do it together. Is we start by identifying what the input is. So the input's minus 2, yeah? Yeah? So, which function do I stick it into first?
G of x.
G of x. Okay, so g of x is 2x plus 3. So I take minus 2 and I do 2 times minus 2 plus 3. And what do I get? Pardon? Negative 1. Okay, so we've got negative 1. You got that, Zoe? Yeah. That answer, okay, this answer then goes into f of x. So I use this one. So then I do x squared plus 2. So I take that answer and let's kind of put it back and we go into negative 1 squared plus 2, which equals
3.
Can you scroll up just for a minute so I can see what g of x is?
so g of x was 2x plus 3. You can see it 2 times x plus 3. F of x was x squared plus 2.
I think I think I get it, but I'm scared I really don't get it.
So the next one then, what's the input?
You do F first.
7.
So we do f of 7 first. That's the first thing I do. So then I have 7 squared plus 2, which equals
51.
51. Okay, I take that solution, and I put it into
G of X.
g of x. Okay,
Which is 102, then 105.
so that would be, 2 times 51 plus 3 is 105, as you said. Okay, that's your final answer. Yes?
So I got the second one, but I didn't get the first one. So the first one, it was G of X first, right?
Yes.
And then G of X is, and then it was -2.
Yeah.
And and then -2 times -2. Oh, it's 2 times -2.
Yeah.
I think I put it into F first, maybe, because then
I think you got negatives
because I
wrong.
got 4,
No, I think you did.
or maybe I just
You just did
I
multiply
think
by
I did it
negative
wrong,
correctly.
yeah.
Okay, does that make some sense then? Zoe, did that make more sense that time round? Ethan, yeah?
Yes.
Yeah.
I made a simple error.
So the next question would be, well, I can put numbers in and I can get the numbers, but there is another way of doing it, which is where, what if I actually asked you for what is fg of x? So I actually just want the function. I don't want a number, so I can put the number in and just apply it. Now, just to make one thing clear here, a lot of people, when they get to this stage, then that's all they ever do. And when they put the numbers in, they try and do fg of x first and then put the number in. You can, but... Right, what do you think fg of x is?
G of x. That's the same thing. So it would be x. I guess that's G of x. Like that's the simplest way of saying it.
In simplified form, yeah.
Yeah.
Yeah, how would you say that?
Well, if you think about it,
X times
what we
2.
do is you take x and do what to it?
Oh, you just do all the functions. You just add.
You just do the function, right? So we do 2x plus 3. I've done g of x. Yeah. What do you do with that answer?
You sum it into
You put it into F of X.
As
As G of X. No, as X.
as x. So 2x plus 3 becomes x. So what we then do is we square it,
and then
add 2.
and then 4.
But how would you just plug the number in, as you said? How would you
Oh
do
well,
that?
see now I need to simplify that, don't I?
Oh.
As much as I can. So I would be saying, well, 2x plus 3 squared is 2x plus 3 times 2x plus 3, which is
4x plus
squared
6.
plus 12x plus 9.
9.
Yes.
Yeah? Plus 2, don't forget plus 2. So actually fg of x equals...
4x squared plus 12x plus 11.
So now if I wanted to do fg of, let's just check, what did I do? Fg of minus 2. If I wanted to do fg of minus
You can put
2,
minus 2 in for those x's.
exactly.
Yeah, the other way.
That makes it so much easier.
Oh, great.
Does it? I don't know.
So then it becomes 4 times minus 2 squared plus 12 times minus 2 plus 11.
Yes, it does.
So minus 2 squared is 4. 4 times 4 is 16. Minus 24 plus 11.
Negative 8 plus 3.
Well, I'm actually going to do 16 plus 11 is 27. Minus 24, 3. Do we agree?
Yeah.
Over to you then. What is GF of x.
Or GF of X.
GF of x
Spicy.
is actually easy.
You just do.
Go for it.
Hmm.
We start with f of x, which is,
X
Greg?
squared.
Oh, f of x becomes x squared. No, sorry. Well, f of x is x squared plus 2.
Yeah.
And
then
then
that gets put into,
I got
g of x.
so it
Square
becomes, I always put brackets around it, and now just imagine that's x, and it becomes then 2x
x squared
plus
plus
3.
3.
So now I can
2x
expand and
squared plus
simplify.
2x squared plus 7.
So it's 2x squared plus 4 plus 3, so we end up with 2x squared plus 7. Okay? So that's g f of x. Simple, right?
Blended.
Yes.
Okay. Question then. Main and range.
Oh.
You're very correct in saying there's two things happening, so we have to be careful. We have to check.
Yeah.
However, if we check both the original functions, does either of them have any problem with?
No.
No.
But once you put them together, since there's 2 lines then, there's a
But is there any
possibility-
x value that I can't use?
No.
No. There will be no issue whether I put them into the initial function or whether I put them into the second function. There is no problem. What about the range?
Y must be greater than or equal to 7.
So y must be greater than or equal to 7. Yeah. Again, there's no problems coming from the initial 2 functions, so that's as simple as it is. Okay? Right, is that? Oh no, we've got 10 more minutes. Okay, so in the book, you've got page 26. Alright. Have a look at practice 2 and problem solving. You pick the point at which you want to work from.